All right, folks, welcome back to 7.5, part 2. So last time we left off on converting from polar form or trig form to rectangular form. And we're going to do one more practice example like that that's asked in a slightly different way before we move on. Okay, so example 4 says find the rectangular form of the complex number r equals 13 and tangent theta equals 5 over 12. So I'm going to go ahead and start by drawing a right triangle so that I can label my sides using the information they gave me with the tangent. So I know that tangent is opposite over adjacent, so that means that this side is 5 because it's opposite from theta, and this side is 12 because it's adjacent to theta. And I also know that a 5, 12, 13 triangle is a special right triangle, but I also know that side is 13 because I know that the radius is 13. Okay, so now let's figure out what information we need. So for rectangular form, I want to start with something kind of like this so that I know what values to plug in. So I'm going to say that z equals r cis theta, or z equals 13 cis of my arctan of 5 over 12. Okay, now it's not a nice unit circle number, so I don't know what it is. I can leave it like that. But now I'm going to expand this. So z equals 13 parentheses cosine theta plus I sine theta. And since we have our whole triangle, we can find our cosine theta by taking 12 and dividing it by 13. So 13 times 12 over 13 plus I sine of theta is going to be 5 over 13. And then I'm going to go ahead and distribute. And when I distribute, I will get z equals 12 plus 5i. And that is the rectangular form of my complex number. Okay, so from here, before we move on, I just want to reiterate that drawing right triangles and knowing your SOHCAHTOA is so useful, especially in a case like this. It might feel like you don't have enough information, but as soon as you draw your triangle using this information, you're able to figure out what you need. Okay, so let's move on to part 2, products and quotients of complex numbers. So if I have two numbers, we're going to call them z sub 1 and z sub 2, and they're in polar form, then we can multiply and divide them using these formulas. So this one is our product formula, and we're going to multiply the r's, but we're going to add the thetas. And if we look at the second formula, it is the quotient formula, and we're going to divide the r values, and we're going to subtract the thetas, okay? So let's go ahead and do a couple quick questions to practice this. So number 5 says, find the product and quotient of these two complex numbers. So I'm going to go ahead and set up for the product one first. Okay, so for the product, I'm going to say that z1 times z2 equals r1, r2, cis of theta 1 plus theta 2. And all I need to do is plug in what I have. So r1 is 3 times r2 is 5, cis of pi over 4 plus pi over 6. And when I clean that up, I'm going to get 15 cis. This turns out to be 3 pi over 12. This is 2 pi over 12. So I get a total of 5 pi over 12. And that's it. I've multiplied those two complex numbers. So let's take a look at what it looks like when we divide. Well, when we divide, we're going to take z1 and divide it by z2. And according to our formula, that means we're going to divide the r's, but we're going to subtract the thetas. So that gives me 3 over 5 cis pi over 4 minus pi over 6, which is going to give me 3 pi over 5 cis pi over 12. Oh, and I just realized that should say 2 pi over 12, not 16. Okay, so there we have it, our product and quotient. It's really just plugging in the numbers from the formula plugging in numbers into the formula. Okay, let's take a look at one last example before we close out this section. So this time we're going to find the product and quotient of these two numbers, and they're in complex form, or they're in polar form, and it's with degrees. But we can handle this exactly the same way we handled the other one. So we're going to take a look at our product first. And so z1, z2 is r1, r2, cis. Don't multiply the angles, but you're going to add them. So my r1 is 2, my r2 is 4, cis 213 plus 33, which is going to give me 8 cis 246 degrees. And that would be my product. Let's find our quotient. z1 divided by z2 means I take r1 divided by r2, cis, don't divide the angles, but subtract the angles. So that will give me 2 over 4 cis 213 minus 33, which will give me 1/2 cis of 180. Now, because 180 is a nice number on my unit circle, I'm going to go ahead and expand this out. 1/2 cosine of 180 plus I sine 180. All right. And if I wanted to, I could actually simplify this just to be negative 1/2, because this part would go to 0. Okay, so this and this are equivalent in this case, just because it happens to be a nice unit circle value. But you don't have to simplify them. You can leave them like this, and that's totally fine. Okay, so that's where we're going to stop for 7.5. Come on back for the last and final section of this chapter, which is 7.6, and we're going to use some of this polar form a little bit more, so make sure to practice it before you show up for 7.6. All right, see you there.